start. It's like the second half of the unit. So the first half of the unit was kind of about numbers, and it was about radicals, right? That's what we did. Now we're going to move on to exponents, which is kind of nice because it's kind of review, right? Like the first couple things should, for some of you, might be like, oh, I completely remember that. For some of us, it might be, I kind of remember that. And some of us, it might be, whoa, I don't remember that at all. Right? But it is somewhat review, which is kind of nice. We'll start off by talking about what an exponent is. We've already kind of talked about that. They like to use like area diagrams and pictures to try to represent exponents. I'd rather not. I'd rather just do the math side of it. So the math side of it is that if you have multiple things, multiple things multiplied together like this, 2 times 2 times 2, we could write that as an exponent instead. So we could write it as 2 to the power of 3 because there's 3 2s. And so we changed to exponential form. We've already been doing that, right? Like we did that with lowest common multiple, greatest common factor. We've already seen this before. So it's like, yeah, okay, that makes sense. It also means you could go the other way, right? So if you had 2 to the power of 3, you could break that up to become 2 times 2 times 2, right? If you found that beneficial for whatever reason. The way they like to represent it is something to the power of 3 can be seen as 3 dimensions. So like a cube, right? Like length times width times height, which that's definitely not length times width times height. I went the wrong way. That'd be length times width times height. That would be the same thing times the same thing times the same thing. So you can represent something cubed with a cube. Probably why they call it a cube. You could represent something to the power of 2 with a square, because it would just be length times width. Right? That's probably why they call it squared. Okay. The other exponents, like you're talking like fourth dimensions, that's nonsense. That's why we just say to the power of 4, to the power of 5, to the power of 6. Awesome. Some words that you're going to need to remember. And I'll try my best. I'm not very good with using the proper words with this stuff, but I'm getting better. With the radicals, I always use kind of the proper terminology. This stuff, not so much. The first word that we need to understand is power. So when I say a power, I'm talking about the entire thing. Like that is a power because it has something on the bottom and it has an exponent on the top. Okay, so this is the power. In each power, you have 2 things. You have the exponent and you have the base. And this shouldn't be anything new to us. The exponent is the little tiny number up here, which you're all very comfortable with, and you probably know that term. The term base we're maybe not so comfortable with. So the base of this thing is just the A. Right? That's the base. And we are going to refer to the base. Right? So I'll say things like they have the same base, they have a different base, and stuff like that. So you need to understand that base means the big number of the power. Awesome. Quick example. A little quick hitter here. We look at these examples. The base of this thing equals 4. The exponent, I'm just going to go exp, is 5. Fantastic. When you have brackets in your power, that means everything inside the brackets is the base. So for this one, the base is -3. If there weren't brackets, then the base would have just been 3, and the negative wouldn't have been a part of it. The exponent on this guy is 6. We can do the same thing with letters. So we have x to the power of y. The base for that is x. The exponent is y. Easy peasy, right? Awesome. You can also have coefficients on powers. So, like for instance, and I kind of just talked about it, if you look at this guy right here, the power to this question is p to the power of 3. The base is p, the exponent is 3. The 7 out front is like a coefficient. So this is 7 times p to the power of 3. That's why brackets are going to become very important to us. Because if I put brackets around it like this, now the base is 7p. See how it changes very slightly with brackets? So when you see me putting brackets on things, it's very important, especially with your calculator. Your calculator is just a machine, right? So it's just going to do what it knows. And what it knows is that brackets mean the whole thing is the base. So be very careful when you're looking at a question and understanding what's the base and what's the coefficient and what's the base, right? Like it's different. We'll look at some examples. We're looking at these three right here. The coefficient on this guy is 8. The base on this guy is x. The exponent's obviously 2, but you guys are always good with that word. All right, we look at b. The coefficient on b is -3. The base is z. Last one's a little bit tricky. Okay, I'm going to give you the answer, but then I'm going to rewrite it to show you why that's the answer. Okay, so the base of this guy. We'll start coefficient. The coefficient is 1 divided by 7. The base is a. The reason why it's 1 over 7. They've just combined that to be a fraction. What it used to be like, and how I could rewrite this, is 1 over 7 times a to the power of 8. That's the same thing. The thing that they've done is they've multiplied the a to the power 8 times 1. A to the power 8 times 1 is still just a to the power of 8. That's why they combined it to be a to the power 8 divided by 7. Right? Just understand that you can go back and forth in between these two forms. That one usually screws people up because it's a little weird, right? Awesome. Yeah, we'll look at a couple of questions. So, for instance, you can see these are 4 questions that are all the same. They all have a 3, an a, a b, and a power of 4. They've changed where the exponent is, and they've changed where brackets are. And if we were to write it as repeated multiplication, then you can actually see what each one looks like and why the brackets make such a difference. So looking at this one means 3 is a coefficient. There's 4 a's, and there's 1 b. That's what that question represents. Because the only thing that's the base is the a. The 3 and the b aren't a part of it. If we look at the one below, they moved the exponent to the backside. So now it's 3, there's 1a, and then there's 4 b's. Because b is the only thing that has the exponent. B is the only base. Then they throw some brackets in and it changes things. This is 3. That's still out front. But now the AB is the base. That means you have 4 ABs. So you have A and a B, and an A and a B, an A and a B, an A and a B. And those things are all multiplied together. Yep.
Would you write it as like A times B, or would you write it as AB times AB?
So you could do it like you go A times A times A times A, and then B times B times B times B, right? If we rearrange this thing, we could say there's 3 and then 4 A's, so we could say A to the power 4, and then 4 B's, so B to the power. So you can see how we could like rewrite this in so many different ways. But this is technically what that means. It means there's 4 A's and there's 4 B's. So the brackets make a big difference, right? The last one, now it's all in brackets. So if you do repeated multiplication, that means you have 4 3's, 4 A's, and 4 B's. So we have 3, 3, 3, 3, A, 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 B, B, B. okay, because they were all part of the base. And I didn't write it in the order like I did above, because I'm just reminding you that multiplication can be reordered. Okay? 2 times 5 is the same thing as 5 times 2. You just reorder it. Okay? That's the same thing as saying 3ab, 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 3ab. But see how the brackets change things, right? Very important. Even with negatives, it's very important. Awesome. We're going to talk about the zero exponent law. We're just going to talk about it by doing this question right here. I'm going to do this one. We're going to evaluate all these things. Evaluate means calculate. Okay, so if you see that terminology, evaluate means calculate. I so cal. So if you do question A and you do 6 to the power of 0 in your calculator, reminder that the power button is like the little hat button above the division symbol. So I go 6, little hat, 0, hit enter. The answer will be 1. Awesome. If you do B and you do -9 to the power of 0, you need to use brackets. If you don't use brackets, your calculator will think that it's negative times 9 to the power of 0. That's not what we want. We want the entire base to be -9. So you go bracket, -9, bracket to the power of 0, and you get an answer of 1. If you didn't get 1, okay, here's a few errors that could go wrong. If you got -1, then you didn't put brackets, okay? So you need to somehow put brackets around that -9. If you got error on your calculator, it's because you're using the subtraction button and not the negative button. Okay, so on your calculator, you have a subtraction button that runs down the side of your calculator. And when you put it in your screen, it's usually pretty big. Then you have a negative button, which is down here beside the decimal. Okay, so if you're ever starting an equation with a minus sign, you want to use the negatives. Awesome. If you do C and you don't put brackets, -9 to the power of 0 equals -1. The reason it's -1 is because 9 to the power of 0 is 1, and then the negative wasn't a part of the base, so it's still 1. The last one, we have 2 times 6 squared to the power of 0. If I was to do that in my calculator, I would calculate what 6 squared equals. It equals 36. And then I would do 36 to the power of 0 times 2. If I do that, I get 2. How we got all these answers? There's a pattern going on. The pattern is that anything to the power of 0 equals 1. It's called the 0 power rule. Right? Anything to the power of 0 equals 1. So for this first question, the base was just 6. There was no coefficient. 6 to the power of 0 equals 1. Plain and simple. For B, the base is -9. There's no coefficient. -9 to the power of 0. Anything to the power of 0 is 1. For C, the base was only 9. So when you calculated this part equaled 1, because anything to the power of 0 equals 1. And then the negative was the coefficient. That's why it became -1. For this guy, we had this thing right here. It equaled 1. 2 times 1 would equal 2. Awesome. Anything to the power of 0 equals 1. Okay, exponent laws. So that should have hopefully that's all review. This technically still review. Just depends how much you remember from Math 9 though. This would have been harder stuff from Math 9. There's a bunch of laws. We're going to start off with something called the product law. And we're going to look down the right-hand side first. That's where the actual rule is. Okay. So this guy says a to the m times a to the n. Something important about the product law is that you have to have the same base for it. Okay? It doesn't work if the base is different. Remember the base being the bigger number on the bottom. This is same base. They're both a. you have the same base and you're multiplying together, then you can add the exponents. It becomes a to the power of m plus n. Awesome. If we, yep.
Would you have to write m plus n, or could you just write mn?
If you put mn, that means multiplication. Good question. So remember, no symbol means multiplication. If you put a plus in there, then I know you mean addition. How that would look with numbers. So you look over here. If you had 8 to the power 3 times 8 to the power 2, it's the same base. So you can add the exponents. 3 plus 2 is 5. 8 to the power of 5. They've explained it by doing all the multiplication. They showed 3 8s, 2 8s. That means there's 5 8s. That's why you add them together. How it works with letters. If you had a to the power of 3 plus a to the power of 2, you would just add the exponents to become a to the power of 5. Awesome. Have to have the same base for it to work. Next law, called the quotient law. It's just division. So if you're dividing with the same base, again, we're going to start on the right-hand side because that's kind of where the rule is. If you're dividing with the same base, it's typically written like this. It's technically could be written the other way too. We want to subtract the exponents, and you subtract top from bottom. Okay, so in our case, m is on the top, n is on the bottom. So it would be a to the power of m minus n. And that's your product or your quotient law. How it looks with numbers, that means if you had 8 to the power of 3 divided by 8 to the power of 2, that would be 8 to the power of 3 minus 2. That equals 8 to the power of 1. How it looks with letters, if you had a to the power of 3 divided by a to the power of 2, that would be a to the power of 3 minus 2, which becomes a to the power of 1. Notice that they didn't write the power of 1 on this one, because you don't need to write exponent 1. No exponent means 1. Awesome. Power of a product law. So this one gets a little bit confusing because we progress through the year and people will accidentally use this law when they can't use this law. Right? The important part of this law is that there's brackets. Okay? The base is two things multiplied together. That's the important part. So on the inside, I have a times m, or a times b. If it was a plus b, this law doesn't work. If it was a minus b, this law doesn't work. It has to be a times b as the base. If you have that, this scenario right here, then what we say is that the exponent comes in to both things. When it comes into both things, it would become a to the power of m still times b to the power of m. And because they're different bases, we can't combine those, right? Because it's a and b. Awesome. How it looks with numbers. That means if I have 8 times 7 to the power of 3, the 3 can come into both things to become 8 to the power of 3, 7 to the power of 3. How it looks with letters. If I had a b to the power of 3, the 3 would come in to become a to the power of 3, b to the power of 3. Just got to fill in the blank of the notes. Cool. The multiplication law inside the brackets is the exact same as the division law inside the brackets. So when you see division inside the brackets, the same rule can still work, which means the exponent goes to each thing. Again, you can't have any subtraction or any addition. So that becomes a to the n divided by b to the n. That's the technical rule, the law. Doesn't work with addition or subtraction. Awesome. With numbers, what this looks like is that the 3 comes into both things. You become 8 to the 3 divided by 7 to the 3. Okay. If you have division inside the brackets, right, the exponent comes into the brackets, ta-da, ta-da, becomes a to the 3, b to the 3. I think the best thing, I don't know why these two laws are the same. Ooh, they're the same. In fact, the next one's the same too. It's just they change between division and multiplication. But the idea is that if you have an exponent outside the brackets, it can come inside the brackets, as long as there's no subtraction and no addition. So like they're basically the same law. It's just that one's multiplication, one's division, right? And the idea is if it's outside the brackets, bring it inside the brackets. And the reason why I say the next one's basically the same thing is because we were already doing it, we just didn't know we were doing it. When you bring something inside the brackets, like this, and there's already an exponent on the thing in the brackets, then you need to multiply the exponents together. And that's why that conversation before about do I need to write the plus symbol is so different, right? Because this one means a to the power of m times n, where if you didn't put it just because you forgot to put it, you're accidentally saying multiplication when you meant addition. If you look at these two, so this one's with numbers, this would be 8 to the 3 to the 2. The 2 multiplies with the 3, it becomes 8 to the 6.
Now, if they just type this into Google, wouldn't it just do it for them?
Yes, but not with letters. So if they had a to the power of 3 to the power of 2, that won't work in your calculator. That is a to the 3 times 2.
So we do still need you on staff.
Slowly.
Okay.
I mean, not a lot.
I wasn't sure if we phased out math teachers yet. I didn't know if that's where we were going.
We've been working on it. Examples with numbers. So
Why don't you all try this one first on your own?
that's what they're gonna do. Yeah, it's perfect timing. So you guys are gonna try these three. Then I'll show you the answer, and then you're gonna try these like bajillion, and then I'll show you the answers, and then we'll do our assignment. So the important thing to know, and like we kind of take advantage of it because it happens all the time. We don't see counterexamples where it doesn't happen, but it will happen at some point in the semester where the base is not the same. Remember, bases not being the same means I can't combine things. In this case, the base is the same, right? It's 3 and 3. If I'm multiplying and have the same base, I add the exponents, so it becomes 3 to the power of 4 plus 2, which is 3 to the power of 6. Awesome. Next one. They put brackets around the -2. That means that the negative is a part of the base. So the other one also has negative part of the base, so that's good. That means they're same base. We're dividing this time, so that means you subtract. You subtract top from bottom, right? So this would be 5 minus 3. That means the answer is -2 to the power of 2. You must have brackets around that so that the -2 is part of the base. If you didn't put brackets, that means the negative's not part of the base, and you're changing your answer by doing that. So make sure you put brackets. The last one, this is the one they call power of a power law. Really, it's the exact same thing we were doing with all these things. If you have brackets and an exponent outside, the exponent can come inside, and you multiply the exponents. So this becomes 2 times 3, which would be 5 to the power of 6. Beautiful. Awesome. Let's do some of these. I saw people are already starting up, so I might as well just rip through them and let you get to your assignment. This. A to the 4 times a to the 3, same base, multiplying. That means we add the exponents. This becomes a to the 7. 4 plus 3 is 7. Yeah.
Do you have to put the brackets or no?
For that one, no, because there's nothing else inside the brackets. If there was any other thing inside the brackets, then yes. If you put the brackets, you're not wrong. It means the exact same thing, right? So I just was lazy and didn't put them. For B is a tricky one that usually gets people. This is x to the power of 6 times x to the power of 1. Right? No exponent means there's a 1 there. So you add the exponents. 6 plus 1 is x to the power of 7. Awesome. For C, we have b to the power of 7 times b to the power of 0 times b to the power of 4. They're all the same base, and they're all multiplied. That means I can add all the exponents. 7 plus 0 plus 4 is b to the power of 11. That's an 11 somehow. Let's see what someone's going to look at that and be like, b to the power of pi, and they're going to be so confused. B to the power of 11. There we go, kind of got it to work. Awesome. For D, we have division. They're same base. I'm going to keep saying that so it breaks into your brain. We have x and x. Division means you subtract, so it's top from bottom. This would be 8 minus 4 is x to the power of 4. For E, same thing, same base. It's y and y. It's division, so it's 10 minus 2. Become y to the power of 8. And F, we have power of a power, right? An exponent outside the brackets. When the exponent comes inside the brackets, we multiply. So this is a to the power of 4 times 3. That's a to the power of 12. Fantastic. G is the same thing. This is power of a power. The 5 comes in, it multiplies, to become y to the power of 25. H, same idea. You have a division inside the brackets, an exponent outside the brackets. This exponent comes to everything inside the brackets. So it becomes x to the 9, y to the 9. Fantastic. The next one, same idea. The 2 comes in, so it's c squared, 4 squared. This one we'll talk about for a second. If we had that, that's not wrong. We've done nothing wrong at all. But sometimes on a test, they might evaluate what 4 squared is. And they might change this and put it in their calculator. And they might make it c squared divided by 16. Okay, so just be aware that sometimes the answers will be written like that. Sometimes it might be written as an exponent. And you need to be aware of how maybe that number changed, right? So if you're going from here to here and you're like, how the heck did they get 16 on the bottom? You need to be aware that they just evaluated something. Awesome. For J, the 6 comes into the bracket to both terms. Right? The S and the T are in the base. So this becomes S to the 6, T to the 6. For K, the exact same thing happens. The 5 comes in, the A and to the 2. We have 2 to the power of 5, 8 to the power of 5. All right. The last one. Kind of a tricky one to deal with. Okay, so that's negative 3pq all to the power of 4. Remember what that negative represents. That negative represents a negative 1. So you could break that up to be negative 1, 3, p, and q. Or when you bring the 4 in, you could write it like this, where I go negative 3 to the power of 4, p to the 4, q to the 4. But notice that I still put the negative 3 in brackets because I need to somehow make sure that negative is also getting the exponent 4. If I got rid of the brackets, now it's not working. Right? So that's kind of important. If you evaluate this, so calculated it, and you use brackets, you should get 81. So the final answer for this question would probably be 81 p to the 4 q. Those are both 4s, not that. This 4 I would probably. It'd be nice if I could like erase nicely, but we can't do that either. 4. Awesome. Feeling good? Beautiful.